Hello everyone, welcome to Reactify Labs. Today we will talk about message queues. Message queues. Okay, so before starting with what message queues are, let's see why we need message queues. Let's take an example of an app called either Facebook or Instagram or let's say LinkedIn also. Okay, so what happens is you made a post on any of these platforms. Okay, and what happens is somebody, let's say there is a person one who interacted with your post. Let's say the person did a like. Okay, person two also did a like, and you did not get notification. Why? It means it is possible that you did not get the notification because the system was busy doing something more important. Okay, uh, things like maybe some update or some creating some other post. Okay, because if we see, if we have something, let's say I made a post, I made a post and I liked a post. Which of these have the higher priority? If you see, if I make a post and this didn't go through, let's say it gets failed, okay, then it's a bad user experience for me. But ux, this is not cross, this is cross, this is ux. Okay, but if I liked a post and the person whose post I liked did not get the notification immediately, did not get notification immediately, then it's not a big deal. It's not a big deal because anyway that person doesn't know if I've already liked it or not unless I am sitting beside that person showing that person that okay, see I'm liking, did you get the notification? We rarely do it, right? So that's not a priority task. So if multiple people, if millions of people are making a post, it is possible that system, due to its limited number of resources, are prioritizing making the post of other people and deprioritizing your notifications of the likes. Okay, for another example, let me take um, another better example would be, yeah, let's say there is a celebrity. We have a celebrity, uh, let's say Ronaldo made a post. You and your friend are sitting next to each other, opening Instagram. Your friend open Instagram, you both open Instagram, and you see that the post has 100k likes, but your friend sees that the post has 102k likes. Again, you will see the 102k likes eventually, but not immediately because the system is prioritizing something else instead of showing both of you the number of likes. Because it's a celebrity post, it's a thundering herd problem that has occurred here, so many likes at the same time. So the system takes some time to process those and notify everybody, and that's why it delays some or it deprioritizes some tasks. So that's when message queues come into picture. Because if I just like the post, then, and the other person is not getting the notification, it means the notification is stored somewhere. It means the notification is stored somewhere, and that will eventually be delivered. So we need message queues for those tasks. We need message queues for asynchronous communication. That's one example of using it for notifications. There can be many different cases as well, right? So yeah, let's start the message queue technicalities and what are the different types of message queues, what are the different uh, mm, behaviors of message queues and different use cases also. Okay, and if we go into the technical definition, message queue is a form of, it's a form of asynchronous service to service communication. Message queue is a form of asynchronous service to service communication used in serverless and microservices architecture. It's used in serverless and microservices architecture. Okay. Messages. So message once went to the message queue, the messages are stored in queue until they are processed. Until processed and deleted. Once they are processed, they are deleted. Okay. Each message is processed only once. Each message is processed only once by a single consumer. Okay, there will be a single consumer for each message. Okay, so what are message queues basically? If you see, someone is sending a message to someone, means my Instagram is sending message to your Instagram, not that notification, but holding it temporarily in the message queue. So basically message queue is nothing but a broker. Okay, so message queues are what? Intermediary components. They are intermediary components in distributed systems, okay, which allow asynchronous communication between different components. And all they do is they pass the message. And why are they important? Because they play a crucial role in decoupling components. They play a crucial role in decoupling components, and they ensuring reliable communication. They ensure reliable communication and they manage varying workloads. Varying workloads efficiently. Okay, so they manage those workloads. Even if the workload is less, they manage it well. If it is more, they manage it well. They deprioritize something. Okay, so if you see here that they play a crucial role here. If you see one more thing, it's this each message is processed only once. Okay, and they play a crucial role ensuring a reliable communication. This reliable communication is one thing, that how they ensure reliable communication. How? I'm not going to talk about that in this video, but it is possible that the message queue sent the message, but the receiver or the consumer was down. It is possible, right? Or the message queue sent and consumer was up and the message got lost. There are different cases which can arise, for which about which I will talk in the next video, because this video will already be large with other discussions. So I'll talk about things like QoS 0, QoS 1 and QoS 2 in another video, in which I'll tell you how message queues ensure that a reliable communication must be established. Okay, because if the reliable communication is not there, then there will be trust issues, and the systems might not provide good user experience, which might not be a good indicator of the user acquisition and retention. That's why message queues need to be reliable. Okay. So about that in next video. Let's focus on other things in this video. So message queues have some functionalities. So message queues have some functionalities. One is asynchronous communication. Why asynchronous? As I told you, when when the notification came and it could not be delivered at that moment because the resources were busy processing other things, so it was held for some time in the message queue and it was delivered maybe 30 minutes later. So that's asynchronous. It's not happening synchronously, right? When you are liking, the other person is not getting notification. It can happen at that time depending on the availability of the resources of the message queue. Next is message persistence. So the message don't get lost. They are there until they are delivered to the consumer. For that also there is threshold and it will not be held for years, right? But we will talk about that later. It's one more functionality is queue management. So message queues handle queue management tasks like prioritization. They know what message to prioritize, because if there are multiple notifications in the queue and somebody else made a post, it knows that the post had to be prioritized, it has to be prioritized. So they will prioritize the post, they will bring it to the front of the queue. Okay. It will retry. If it's not successful at the first time for notification or post, it will retry it. And they monitor message flow also. Monitoring message flows, right? So these are the functionalities of the message queue. Let's see what are the benefits now. So what are the benefits of message queue? First one is decoupling. So message queues decouple sender and receiver. Sender does not need to wait for anyone or anything. They decouple sender and receiver, thus allows components to function independently and asynchronously, thus reducing the system dependencies. Okay. Next is reliability. Reliability and resilience. As I told you before also, the messages will be delivered, so it's a reliable method. And resilience means it, if it does not get delivered at the first try, it will keep trying until it's delivered or until some threshold is exhausted. And obviously scalability and flexibility. Message queues enable scalability by distributing workloads and handling peak traffic effectively, and this way it also provides flexibility, right? So if there are so many good things about it, there must be some challenges also, right? Because no good system comes without its challenges. Just a rule of thumb, I would say, the more sophisticated or the more useful a system looks like, the more complex its challenges are, right? So, for example, calculator. It looks like very simple thing, right? So if it's simple, simple means cannot do a lot of things. Difficult also, difficult UI, difficult user interface, as in you have only one small screen to do everything. So its implementation is also simple. But if you just see a laptop, okay, you can see it's simple. It simple as in simple to use. Great UI means very sophisticated. Then it means it's very complex. Everybody makes a calculator, but not everybody can make a computer or laptop, right? So that's the rule of thumb. So now the message queue is doing so many things, then obviously there must be challenges associated with them as well. What are the challenges? First one is obviously complex implementation, because it's making our other tasks easier. So obviously the making of it, the implementation of it must be complex. Implementation and management of message queues can be complex, and they require careful setup and monitoring within a system. Another is message ordering. How do you order the message? How do you decide which message to take priority? Maintaining message order in different scenarios involving concurrent processing can be challenging and requires special consideration. It can have potential bottlenecks also. Potential bottlenecks. If we do not manage it properly, it might lead to message queues becoming performance bottlenecks. Because obviously everything has a limitation. So message queue also has a limitation. What if multiple post request comes? Who will get priority? So we need to handle these things. Multiple message queues, parallel processing, things like these need to be handled. Okay. So now that we have talked about these different challenges and benefits, let's talk about different message queue architectures. So message queue architectures. What are the different message queue architectures? First one is broker based architecture. First one is a broker based architecture. So this architecture, it employs a central message broker. There is a central broker which is responsible for managing message distribution among various system components. Okay, this broker acts as a middleman which receives messages from producers, stores them, and delivers them to the subscribed consumer. Okay, as I showed you, producer, message broker, consumer. Okay, this is a broker based architecture. What are the advantages? The advantages of this is it has centralized control. Centralized control, so good thing. Only one place to manage everything. Scalability, okay, and reliability. It ensures reliable message delivery with persistent storage and acknowledgement mechanisms, and it allows scaling by adding more brokers or enhancing the capabilities of the existing broker. Okay. Next, the challenges that come with it. Challenges include, as we all must have understood by now, if there is a centralized something, it will have a single point of failure. It will have a single point of failure. It's it is scalable, vertically scalable, but scalability is limited because there is only one, right? Scalability is limited and latency is increased. Increased latency. Message routing, because it's going through a central broker, so there can be bottlenecks, performance bottlenecks, because there is only one to process everything. And if the system is large scale system and it's geographically dispersed, then this problem will come. Okay. So where do we use it? Where do we use this? Use case is it's prevalent in enterprise systems and messaging middleware where centralized control and reliability is crucial. Where enterprise systems and messaging middleware. It's crucial here. Okay. So this was all about broker based architecture. Now let's talk about a different architecture, which is peer to peer architecture. Let's talk about peer to peer architecture. In contrast to the broker based model, peer to peer architecture facilitate direct communication between nodes without relying on a central broker. So there is no central broker here. It's a peer to peer architecture in which nodes communicate directly, establish connections, and share messages without intermediary routing or through a central entity. So there is no central entity. The nodes talk directly to each other. Okay. So now let's see what are the advantages of this. The advantages include, first one, decentralization. If there is no decentralization, there would be no single point of failure, right? Second is lower latency, because now the bottleneck is not there, so latency is removed. And simplified scaling. Scaling is simple because new nodes can be added and removed without affecting the entire system, right? Next, there will be challenges associated with it as well. What are the challenges? One is complex coordination. If the node to node communication is happening directly, then it might introduce complexity in managing connections, routing, and ensuring reliability. There is a potential for inconsistency. There is a potential for inconsistency as well, because there are different nodes. If they do not communicate amongst each other, there will be inconsistencies. And there can have security challenges as well, because peer to peer communication is there, so it will have a security challenge, because we need to take care of the security from the point of view of each node. In the broker system, there was a centralized entity and we could implement security mechanism in that, but here we have to take care of security in all the nodes. Okay. And if we talk about use case, where are these used? It's common in decentralized systems, edge computing, edge computing, and in those scenarios where fault tolerance and autonomy is critical. We need fault tolerance, right? We cannot have a single point of failure. Great. Next, there is a combination of both peer to peer and broker based architecture, which is hybrid approaches. So, hybrid models combine elements of both broker based and peer to peer architectures, and they offer a blend of centralized control as well as decentralized communication. They leverage the benefits of both the models by having multiple brokers for localized control while allowing direct node to node communication when necessary. So, what are the advantages? The advantages of both the centralized model and peer to peer model. So it will provide flexibility in communication patterns, allowing dynamic adaptation based on the nature of the message, scalability and resilience, right? And tailored solutions. Depending on the kind of requirement that you have, you can tailor the how much portion will be centralized and how much portion will be peer to peer. Okay. And challenges challenges would be complexity in implementation. We need to take care of the implementation of both the centralized and peer to peer architecture, so there would be complexities. There will be a potential for conflicting patterns. There will be a potential for conflicting patterns, because balancing centralized and decentralized communication might lead to conflicts and inconsistencies in message routing strategies. And obviously there will be increased overhead. Why? Because maintaining both broker based and peer to peer components will introduce additional overhead and complexity, which is something obvious, very obvious. And what are the use cases? Hybrid approaches find application in complex systems that demand dynamic routing, dynamic routing, fault tolerance, and tailored communication patterns. If somebody wants that, then hybrid approaches are good for them. Okay. Let's talk about some of the popular message queues. If we talk about some of the popular message queues, there are, first one is RabbitMQ. So RabbitMQ is an open source message broker. It's widely used for its robustness, flexibility, and easy integration. It's generally favored in microservices architectures, job queues, and distributed systems because they support different message protocols. Second one is Apache Kafka. Apache Kafka is a distributed event streaming platform. It's known for its high throughput, fault tolerance, and scalability. Kafka is mostly used in real time data pipelines, log aggregation, and streaming analytics due to its ability to handle high volumes of data. Next is Amazon SQS, Simple Queue Service. SQS is a fully managed message queue service provided by AWS. It's extensively used in cloud based applications and AWS ecosystems for reliable message delivery and decoupling components. Okay. Next is ActiveMQ, Active Message Queue. It's also an open source Java based message broker that supports several messaging protocols. It's widely used in enterprise systems. It facilitates communication between distributed components and supports various messaging patterns. Next is, sorry, next is Redis PubSub, publish subscribe. Redis is primarily a key value store. It also offers a publisher subscriber messaging mechanism for real time communication. It's used in scenarios where real time data sharing among different components or services is necessary, often in applications requiring speed and simplicity. And one more we have Google Cloud PubSub. We have Google Cloud PubSub. It's a fully managed messaging service provided by Google Cloud Platform (GCP). It's suitable for event-driven architectures, data streaming, and cross-platform communication within GCP-based applications. So you must be wondering why I just quickly moved through these topics. It's because nobody is expecting you to remember what each type of message queue does, and it's not possible also unless you start working, unless your project is on one of the message queues. Then you should be good and you should know about that particular message queue. Obviously you should have a high level understanding of what each does, but at a high level right now while preparing for interviews you are good with message queue, just knowing what message queue does. And each message queue that you will be asked when you have some levels of experience, and if you write in your resume that okay, I have experience with Kafka, then they may ask some things about Kafka, and if you have experience about Kafka they will not ask you about RabbitMQ. So that's why I did not focus more on these topics. I might focus it later. If you want, I'll make more videos on each of these topics talking about these in detail, but for now, for this video, this is good. And now I think I have covered everything. One is the QoS thing that I did not cover, that I'll cover in next video. And I hope the examples seem relatable to you and you like this video. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.